So question, that the other time we did, I think we did a lot of questions, but I think today we can do more for this. So what is the mass of, we're just recalling, we're just helping ourselves. So I'm not going to do this one that has already been formed. I'm going directly to an example so that we check, and then we continue. And then now we go to the empirical formula. Now, the reason why I'm doing this is because now whatever we're going to do here, that is the empirical formula, the molecular formula, all of them is related to what we did the previous time. So I just want us to recall a little bit. Then we continue. So exercise 2.2, maybe we can do, so question 1, I don't have a problem with it. And I said the previous time when we met, it is more important for you to know the formula, which is the chemical formula, rather than the English name. For example, copper 2 nitrate. So copper 2 nitrate is written that way in English, but now it is very important for you to know. Now, a nitrate is a radical, so you should know how to write those texts. So we can start. Let us do even one. We can only do one for the sake of this one. For the sake of the next subtopic, maybe, which is the empirical formula, the molecular formula. So let us only do. We can do. I think we can do question 1, but in that question 1, we only do maybe 1 and 4. We don't have to do everything. Huh? And then we do now the molar mass. We can calculate the molar mass because it is going to help us somewhere. We can calculate the molar mass. I'll give you the individual masses for the rest. So let us do, maybe I'll do question number, let me do question 1. There's a reason why I normally do I want to do question 1. And then you can do 2 and 3. And then we do question 6. I think that one, because of the more than 3. Is it more than 3 elements combining together? So I'll do question number 1, which is copper 2 nitrate. So copper is normally Cu. I'll just write it now the way it is normally written, the way you normally form that thing. Cu positive, 2 positive, and then the nitrate is NO. I hope everybody can see the screen. 3 negative. So it is a radical, but with a valence of 1. So it is a radical with a valence of 1. This one is something that you did in form. I think it is done in form 2. So I'm just going through them. But it is very important for you to know how it is done. So this one, yeah. So this one is -1. It is normally -1. Or when you see negative or positive, it is 1. So you will come to this side. Do you remember how it was done? And then now the 2 of this side will come to this side. Nakuja this other side, opposite side. So whatever you get, you are changing the valence. Now, this one again will be affecting the form 4. There's a topic in form 4 that these ones will come most of the time. We'll be talking about this one. But of course, we'll be talking about the oxidation state. Now, the oxidation state is the same as the valence. The only difference is one have a sign, the other one does not. So there's no problem. And of course, when you talk about the valence, you're talking about the number of electrons, especially when you're talking about single elements. Single elements. So you'll find that Cu. So I had tulikuwa tumejifunza hii Cu, and then it is 1. So when you're doing that, you take out the signs. You don't have to show the signs whether it is negative or positive. You only show what it is, a number. And then the nitrate is, remember, it is N. And try to write the way I've written. I'm trying to write very well as much as possible, although I'm using the cursor. 3. And then because you have another number outside, when you have another number inside, what you do is you open a bracket, and then you close the bracket, and then you put the 2 outside. So we do not normally show this one. So mara mingi utapata imeandikwa copper 2 nitrate, but now it doesn't have this one. So we assume that 1, you know that it is already 1. Of course, it is 1 there is no this one is already 1 without even writing 1, but now 2. Now, if anything happens, I was telling you the other time, this one, when you do this and you mess up the formula, the mass, the molar mass now, which you are looking for, which is here, the molar mass normally changes. And if you change the molar mass, that means the concentration will have changed. Or you will score the answer, or you get it wrong. So that is why it is very important for you to know how to, write the formula first, before even you calculate the mass. I don't know if we are better now. We are going to do the empirical formula today. So I'm going to handle empirical formula only today. But I wanted us to remind ourselves of how these ones are done. Because the next time now you'll be told to write the chemical formula. So I don't know, maybe you can do for me, let us do ammonium sulfate, ammonium phosphate. Now I'm doing ammonium phosphate for the sake, but I think I mentioned the other time that phosphate, it is a radical which belongs to which it has a valency of. So let us try that one. So let me say, how many are we? I don't know how many we are. Let me confirm. So we are around 3. Kila mtu tufanye yake and then we see. So the first person, I don't know, Mwaura from the screen is Mwaura, and then Wendo. You don't have to tell me the answer. You can just post it on the wall if you can't. And I think I saw Monica. So we do, let me say, this is for Mwaura. I don't know. We have done copper, so we do sodium. This one belongs now to op, and then this one belongs to Monica. I think I saw Monica somewhere. I hope she's still in. So let us solve only the 3 of them, and then now we can do. Oh, I'm sorry. Let me go back to that one, and then we go now to the empirical formula. And then I'll talk about that. We are only reminding ourselves. Things there are a lot. Let me rub all this first. I forgot to remember those. So let me rub this one first, and then I can. This book, I'm saying, if you have the long one, it has very good examples. I don't know if I am okay. I don't think this one is where I think it is a little bit low. So this book is very good, especially if you are doing more examples here. So we have the composition of by mass. Yeah, I know I'm getting lost in this book. I don't even remember the exercise that you're going to solve. So we were just doing a revision, but if we don't get this, there's no problem. We don't have to waste a lot of time looking for where it is anyway. But I wanted us to know how to write it is very important for you to know how to write so that one is something different. I don't know if I moved very far. What is this? What is this? Conversion of molecules. If I don't get it, there's no problem. I solve now the empirical formula. I'll come back to that one. Huh? There's no problem because you don't have to stay on it for long. That one is more. We just wanted to remind ourselves. It's basically an introduction of that topic. This one is a different book. I've not been using this book. That's why I don't know. It's bringing a lot of problems. I've been using the other KLB, but I saw this one now for the empirical formula. It has more. It is better. It is better, slightly better than the KLB. So this one is the same thing. These are the same questions that we're going to solve. There's no problem. This one is how the formula of compounds is formed. What I was doing now, where you exchange the valences. So, but I wanted us to do one. but it is okay. Let us just go to empirical formula. I want to use the KLB, and then we'll use this one for examples. So let me unshare first, and then we will see. But the examples we'll use for the examples we'll use the Longhorn. So please allow me to share this one. Yes. I hope everybody can see now. I want us to start the empirical formula, but we'll come back to that thing. It is in the example still. So we'll just remind ourselves when we'll be there. So empirical formula. Now, most of the things we talk about the empirical formula, I'll not talk about how this one is done, what we are doing, but I think we'll skip the example to the examples directly. So the empirical formula of a compound. So I hope you are not you don't feel bad that we didn't do the example, but I know we'll get it here again. I'm saying the examples will be done. It must be, especially when you're dealing with. I wanted us to know how to. The most important thing is how to write the formula. That is very important, which I know we'll do it again. So the empirical formula of a compound, it is a formula that shows. We normally say is a formula, or we normally, it depends. The English doesn't matter. The most important thing is it shows the simple whole number ratio in which atoms combine to form compound. All simple whole number ratios. Now, I want to be very specific about the word simple whole number ratios. Now, when you talk about simple, the ratios that we are going to do, you will be finding one, for example, 1 to 2. That is a simple whole number ratio. If by any chance your answer is 10 to something, or we are saying 10 to 50 or to 54, this one is not a simple. This one now is not simple. Anything that runs from 1 to 9, or we normally say single digits. Single digits. Now, which most probably, most of the time, I put at a 5 when you're dealing with the calculations. So it is simple whole number ratios. The reason I'm stressing this one is sometimes you get your answer. If you get your answer to be more than 10, the ratio that is 10 to something, that is a lot. That is not simple. That is not simple. And remember, it is again something that you are supposed to remember is all number. A whole number is not 0.5. It is not a half. It's not a quarter. It's not 0.75, 0.99. That is not a whole number. It should be a full number. Full number is 1. Now, in this case again, 0 does not come in. We don't consider 0 as a whole number because it actually cancels out everything when you multiply. So, and the formula now is determined from experimental data. Now, this experiment is now, we want to say what is formed when we burn magnesium in air. Now, the good thing about this one is actually you know that the formula is magnesium solid. So if everything gets bad and you decide you are forgetting how we do the relationship between moles and RAMs. Now you can write the formula. I normally advise students, but now the problem comes in when you say when you don't know how to write the chemical formulas of, for example, they're saying alcohol burns in oxygen and then you produce CO2 and water. That one again comes to this place. So if you write this one, If you write what you are taught in Form 1, I think this one is the reaction of metals with air, which normally air, oxygen is the most. So you'll find that you are getting magnesium oxide, but these are now you put 2 and a 2 here. So if the empirical formula does not look like something like that, then you are wrong. So I'm saying empirical formula, and now let me show you what I'm talking about now. Simplest whole number. Now, before even I write the 2, let me just remove the 2 first. These 2. Now, when I talk about simplest whole number ratios, I'm talking about the moles combining. How many moles of magnesium is combining with oxygen? So you are seeing this one is 1, alafu hii pia ni 1. So the moles of magnesium and the moles of oxygen is 1 to 1. So it qualifies as the simplest whole number. We are just doing an introduction. Of course, we'll see how it is done. Now, let us just see how it is done. But I'll skip most of those. Now, I'm saying the empirical formula again is basically, it is based on experimental data. So most of the time, you might find that you don't get a whole number, but we do not allow you not to use the whole number. If you get, for example, 0.99999 something, that one you round off. Now, if you get a value that is, for example, 0.5, 0.5 is like half. So you can multiply by 2, but we'll see those examples. You don't have to be worried now. So what formula? So we'll have, so the first thing, if you are to do this one, most of the time I will not ask you. Now, this question or this subtopic, sorry, this subtopic, the empirical formula, most probably comes in the theory part. So the experimental part of it normally is not tested most of the time, but it is better for you to. No, it is. I normally say it is better to be safe than sorry. So we weigh a dry crucible. So we weigh these ones. So the data will be weighed the crucible together with the lead. Now it is okay. You clean the magnesium, because you know that when magnesium is stored, it normally has a coating of magnesium oxide. Of course, that prevents it from being eaten away. So you weigh about 15 centimeters length of, and then you know the mass. So you know the mass when you weigh this dry crucible. First of all, you know the mass with the lead, and then you clean this one magnesium, and then of course now you can weigh again the magnesium. It is very important for you to weigh the magnesium. In some cases, you don't have to weigh, but it is very important. The first thing is to clean. Now you put it inside the crucible, alafu ufunike. That is replacing the lid or placing the lid, and then you weigh again the crucible. So the reason I normally advise students to weigh the magnesium first is so that you can check whatever comes after. This one is experiment. It can be done. So I don't know. There's a link I was shared with by a friend of mine. I don't know. I've not opened it. It was shared yesterday night around 12. So sijaifungua, but it was about experiments. I don't know. I'll open it. I try first before I give you. Maybe it is a link that can destroy things, or it has inappropriate information. So you weigh again the crucible together with the magnesium, and then you hit the. So that means you are weighing to check out if the weight that you had of the magnesium is true, and then you hit the constant strongly, and then now after eating, we do the same process now. When there are no more flaring ups, of course, when you eat magnesium, I want you to remember that when you eat magnesium, it normally burns brightly. There is a bright flames. Remove the source of it, and then replace the lead and weigh again. You see what is happening? So we are weighing twice. Now, what is very important is this one now. The other one was just a process or the procedure of doing that thing. What is the mass of the lead and crucible? So you're looking mass of the crucible plus mass of magnesium. Now mine, what I did here is niliweka mass of magnesium first before kuweka kwa crucible. I hope that is okay, but the magnesium must be cleaned. And then mass of crucible plus magnesium oxide, that is after heating. Now what happens? Plus the magnesium oxide plus the lead, and then you can get the mass of the magnesium yenye tulikuwa tumepima, but you can still minus or you can still subtract before, and then mass of the magnesium oxide, mass of oxygen. That one's now we have these questions. Now these ones is something that was done in Form 1. Why is it necessary to clean the magnesium ribbon? I'm not going to touch on that one for today. Why was the lid kept on the crucible at first? Why was the lid kept on the crucible at first? What was the purpose of it? Occasionally lifting the lid. Why are we occasionally lifting the lid? You remember we are burning magnesium in oxygen. So oxygen yenye iko ndani ikiisha, you must replace the lid. So unainua ukifunga, you open ukifunga, so that oxygen can get in. That one is very important. Why was it necessary to heat the crucible until there is no further change in mass to ensure that all magnesium has been used up? So these are things that were taught previously. Of course, why was the lid kept on the crucible at first? Why did we keep the lid? So that we ensure that there is no oxygen coming in before the experiment starts. So we ensure that the magnesium is clean. So why is necessary until that one. What masses of magnesium combine to form magnesium? So you do those are now are experiments that you will do. Tell the possible sources of error. So error is human error, which unaweza shindwa kuclean, maybe you could clean vizuri the magnesium. The width, maybe ukiweka magnesium, some of it was reoxidized, ikaoxidiziwa tena before umalize kupima. Those are the errors that could have come. So we have not calculated the most. So it is very important for you. So I'm not even very much into that because we are going to do a calculation. But I wanted only to tell you that one. That is why I'm moving a little bit fast. But if I'm moving too fast, you can still tell me. It combines to form magnesium oxide. Of course, there is a color. So the magnesium ribbon is clean so as to, at the start of the experiment, so as to remove any oxide film on it. Nilisema magnesium ikiexposiwa kwa hewa, most probably it becomes oxidized. So inakuwa na a layer of magnesium oxide on top of it. When carrying out, it is important to keep it in place to prevent the solid from escaping. I said that, of course, when you're doing the experiment, you must close the lid because of the reaction is very explosive. So utapata magnesium inarukaruka. So also it is necessary to leave the lid time to time to allow air in. We eat mpaka ishe because we want to ensure that all magnesium has been used up. And then now we can now calculate. We divide the masses. Now, if these ones are the masses, so this one is something. I think the reason I'm doing this one is because I don't know if it was last year's KCSE or the other years. There was something like this. I don't know, Maura, was it last year's KCSE or the 2024? They were given something, but now they gave out. It was last year or 2024?
No, last year it was just empirical formula.
Yeah. So the other year, they gave out now mass of something for a mass of crucible plus lead 1920, mass of crucible plus lead plus magnesium. You see, sir, we can get the mass of magnesium when you minus this one and this one. You can get the mass of magnesium, which is B minus A. You see, B minus A, which is 0.84, which we are interested in. The magnesium oxide, we still can get the formula. But now the reason why we are getting the magnesium oxide is so that we can minus whatever we got, so that we get our mass of oxygen. So it is there. This one, it is very essential for you to be very keen when you have a question like this. I think we look for a question like that. I am very sure we'll get a question like that. Yeah. So now we go the formula and how we determine. The reason I was going through that one is because of there was a time they gave out and students got confused. So this one is about reading and understanding the question. So for example, tumepata mass of magnesium because we can, but we don't have now the mass of oxygen. Somebody atauliza hakuna mass of oxygen. But remember, the magnesium oxide, hii pia ni, this one is oxygen. So you minus your oxide from your magnesium. That is why we are saying it is E minus D, and then you get the mass of oxygen. Ukishapata those masses now, so we go now to our formulas. We'll do more examples. There's no problem. So yeah, reacting masses in grams. Tulisema grams. So you have 0.84 for magnesium and then 0.56 for oxygen. And then RAMs. Very important. Nimesema relative atomic mass. Sijasema relative molecular mass or the relative formula mass. Because hapa inaletanga shida dogo for students. So this one is very important. Relative atomic mass. Now the number of moles, now this one they have not given us, but we already know that the number of moles is equal to mass over RAM. RAM. So the mass is 0.84, RM is 24 for magnesium. It should be changing depending. So 0.56 over 16. Now whatever you get, now after you have gotten that one, there's something that it is not mentioned in this one, but I have to say. You divide by the smallest value. For example, this one is 0.35, now is 0.35. So in this case, you are lucky. Both values are the same. So you make it simple. So you divide by the smallest 0.35 over 0.3 over 0.35. Una divide tu na yenye iko hapo. So you'll get mole ratio is 1 to 1. You divide by the smallest value. Yeah, not the, you know, this one came down a little bit. Upper June do not divide by the small. But since these one are the same now, the mole ratio will be 1 to 1. That means one magnesium is reacting with one oxygen. You don't write the way I've written, I'm just showing. But it is normally saying Mg1 and an oxygen 1. Those are the mole ratios. So which will give us now magnesium. So I'm saying you can write the equation uone kama umepata. But most of the times, you might not really get the right answer when you write the equation. Very few get the right answer because it is simple or number ratios. So unaweza kosa kufikisha mwisho. We'll do an example that I show you. So you kama tuko sawa, but I wanted people to understand how that one comes in, especially how we get the values. So, but most of the time you could be given a question directly, which Mauro was saying. Now let us see this one. Any variation is due to experimental errors. So we have errors. So sometimes if we did this experiment in the lab, we might not actually get 0.84, 0.56 as the mass. Tunaweza pata 0.6. That is for oxygen. We get mass ya magnesium equals 0.9. And that is because of errors. Experimental errors. We have a lot of errors. I'm saying, of course, the main error in our case is human error. Human error. Alafu we have now the equipment error. Because you're doing the measurement inaweza leta shida. So those are the things that you're supposed to know, because sometimes they'll ask you what could have caused the difference. So you have the human error, environmental influence. That is maybe some of us, the temperature affects the rate of reaction. Pressure affects the rate of reaction. Those are the environmental factors. We're just mentioning that one, but we are not in that today. We're just dealing with the calculations. So this one is another one. This is another one. I don't know. Of course, there's something that normally comes in with this one. They normally ask you to what is the what is the observation made in the combustion tube? Up. The observation made in the combustion tube. What is the observation made here? Observation is before and after. What did you see before? What did you see after? For example, copper color. I don't know, copper is normally, is it brown? After, the solid that is formed is black. Yeah. So that one is observation. So it is very important for you to know the observations. Now we are not in that today. I think that one is in another class. So the observation in the combustion tube is very important. Now I want to, so we have, it is being repeated the same thing. Huh? We repeat the same thing. I don't know. I'm not touching on that one, but I'm touching on this one now. So you see, when you write copper plus oxygen, you still get CuO, which is copper 2 oxide, which is now 1:1. So, but now let us now, percentage composition, you can do the percentage composition. I think we'll do that one somewhere. So let us now do an example. Now, I don't know if you're okay. Maura, have I moved too fast? Because I wanted us to do the calculations themselves. Nimewapeleka mbio, should I repeat something or we just continue?
Yes,
Yeah.
yeah, okay.
It is okay. Now,
No,
for an
teacher,
oxide of silicon, yes.
there was okay. Kuna mahali hapo I wanted to ask a question.
Can I go back so that you ask from that, please?
Yes, yes.
Yeah, please.
Yes,
Please. Is it copper or the magnesium?
Determining the mole ratio.
Yeah, okay. So we can use any, no problem. Let us use for copper instead of
No,
going
I
too
just
fast.
wanted that one. I just wanted the one because nilikuwa nimefanya and I had something different.
Okay. No problem. We go back there very quickly. This one now.
Yes. Okay. Getting the mole ratio. So you have said we get tunachukua hiyo mass of a relative atomic number, relative
Mass.
atomic mass. Yeah.
Yeah.
But sasa I want in my calc when I divide 0.84 divide by 24, I'm getting something different. I'm getting 0.035.
Okay.
Now
what about when you divide 0.56 by 16?
yeah, like 0.56. Yeah, 0.035 also.
So it is the same. So the only thing that the error that is here is the decimal places that have been given. Huh?
Yes.
So instead of this one should be 0, which is very important. Actually, that is very important. It is 0.035, something like that.
Yes.
And then this one also is
0.035.
0.035. So the only thing that is changing maybe is decimal, but now we have the same value. So you can still, the mole ratio now, you divide by the smallest. So I'm saying this one we were lucky because the smallest is the same.
Yes.
So that is why
Yes.
you divide. So you divide this one by also 0. Thank you very much. This one is a typo. This is a typo. That is why, but it was going to be corrected in the other questions because this one is not ours. This one you're only doing what we already been done in the book. So, but it is very important to confirm your decimals because sometimes. So this one, 9 inakuwa 1. This one also, and this one becomes 1. So that is why we need a calculator. But thank you very much, Monica. Yes, I want us to do an example so that we see how it is done. Now I'm going to do maybe 2 to 3 examples. You are going to do another 2. We are going to do for the KLB first. I don't know, KLB is normally an easy one to handle, and then you go back to the other one. And then we see, kama hatujaelewa, we do again another example because now, if we do not understand this place, we are going to have a problem in the next one. we are going to have a problem in the other formula, the molecular formula, the molecular formula. We'll have a problem. So this one is the introduction of the molecular formula. So you have to know the empirical formula so that you can handle the molecular formula. Now, an oxide of silicon was found to contain. Remember, nilisema if you're not given the mass, kuna pahali tulifanya hiyo swali. If you're not given the mass, we will do those examples. So if you're not given the mass and you're given percentage by mass, you use the percentage by mass. Because you don't have to be, what is the empirical formula of the oxide? You don't have to be worried. Now let us go this way. We only do this one. We only use this example. There's no problem, so that I tell you what goes on. Now, elements. So the first thing is you identify the element, which is here. So we are going to solve this one. We are going to solve this one. What? Now I wanted to do that so that I can zoom. I don't like this thing. Yeah, I think that one is okay. And then I minimize this. Yes, I think that one is better now. So an oxide of silicon, just saying an oxide of silicon, so there's no problem about that one. So you just have to check. So we have percentage composition. So they are saying we found silicon is 47% by mass. So oxygen, that means it is the 100%. That is you remember to, I think we handled that one somewhere. Minus, or you subtract 47. So that means you get the percentage by mass of oxygen, which is here. The relative atomic masses is always given, and this should be 28. It should not be 8. Let me just correct that one. Now that is the problem of books now, especially the older version. This one is a very old edition. Yes, I think it has been updated. If you have the newer version, there is no problem. So we have 28. The relative atomic masses is 28, and then you have the answer. So the number of moles now is the percentage composition in a percentage. If you are not given the percentage, you are given the, so utaona hapa ni mass, actual mass in grams. So sometimes unapewa in the mass in grams, sometimes you're given in percentage composition over the ROM. Now, and then you get the answer. You get 1.68 when you divide. I don't know, you can confirm. And this one you get 3.31. We confirm. Let us confirm so that we don't go wrong.
It is 1.68. It is okay.
Yes. And then the other one is, so we, is it 3.31?
Yeah, it is okay.
Yes. Now, what the reason why I want to solve this question, actually mukiona, without writing myself, because I normally, this one is clearer, is because of this. Now, remember, huko juu nilisema you divide by the smallest. Which one is smaller between 1.68 and 3.31? Gani ni ndogo? 1.68, yeah? So you divide, yes, so you divide by 1.68, na hii pia by 1.68. So you will get now 1, and then the other one is, I don't know if this one is the correct, but I think it is correct, 1.94. Yeah, I hope it is correct.
Teacher, mine is giving me 1.997.
No problem. The reason why it is giving you that one is because of these decimal places. I think we truncated this one, 3.31. I think it should be a continuous process. I think it should be moving. It should be a longer number. Eh? So there's no problem. 1.97. Now, nilisema if you have a decimal place, that is not enough. You remember pale nilisema kama sio nusu. For example, if this one was 1.5, when it is 1.5, you multiply by 2. This side na hapa by 2. Iko sawa? When it is
Yes.
a decimal that comes midpoint of the number 1. For example, 3.5, 2.5, 3.5, 4.5, you multiply by 2. But when it is a number that is 1.9 something, now we normally say the good, you round off to one decimal place or to a whole number, because our, remember, empirical formula is simplest all, it is a whole number. So we want this one to be a whole number. This one is not a whole number. So we want that one to be a whole number because our definition is the empirical formula. And what are we looking for? We are calculating the empirical formula. Now, empirical formula inasema it is the simple whole number ratios. So lazima hii ikuwe whole number. If you get a decimal, make sure that one becomes a whole number. So that is why we are making it a whole number. How do we make a whole number? It's 1.9. We make a whole number 1.5 by multiplying by 2. Inakuwa whole number actually. Or you do this. You can write in a proper fraction. We'll talk about that one when we cross that bridge. Wacha tuachane na hiyo kwanza. So this one you make it a whole number. So how to make a whole number is, because this one is past 5. Yeah, imepita 5. So we'll multiply by 2. You just inaitwanga aje kwa hesabu? What do you call that process of making this one 2 rather than 1.9?
Rounding off.
Yeah, so we round off to 2. Yeah. So we round off to 2, and that is wow. Now, ukisha round off now, whatever you get, let me rub this one, qualifies as a whole number ratio. So you will have one silicon, and actually when you go to the periodic table and you check, you'll find that the empirical formula silicon is it in group 4. So you will find that it is the empirical formula now is Si. Now before we come down there, 1 oxygen, 2. Na nilisema 1, you don't really have to show. That is why inakaa hivi. But if you show again, ukiandika hivi, you still score your mark, because now sometimes you forget to remove the 1, which there is no problem. So ukiwacha haina shida, ukiweka bado haina nini, haina shida. Iko sawa. I don't know now if you have understood. The only issue that I have here is here, this place. If we have understood that place, we can continue. Where I'm saying we want to agree with the formula. Those are very easy. Let me just use these terms. We want to agree with the formula. Oh, the formula definition, that is, it is simple whole number ratio. That is why atuachi kwa 1.9 tunabadilisha ikuwe nini? Whole number, which is now 2. Let's do another example. I hope this one has so this one again is the same. The percentage composition by mass of oxide of iron is 70% iron and 30% oxygen. Determine the empirical formula. Do you think you can try this one? Can you try this one? Munaweza equally, or I solve it. There's another example I want, but it is not this one. Can I solve it? Oma mujaribu kwanza? You decide. If you say I do it, I do it. There's no problem.
We can try it, sir, then because of the
Yeah.
donation.
Yes. But you try it and then we do it again, the same thing. So let us try it. I'm giving you how many minutes? Let me give you the 3 minutes. I'm giving you the 3 minutes. Let me get water, drinking water also. So I'm seeing some answers have streamed in, so we just have to check. Hopefully we are getting the same answers. I pray that we are getting the same answers. So FO2. Okay, I think we can see. That is when you're talking about the percentage by mass. So let us continue. Let us check if this one is true. So you have the composition. So you have, first of all, you identify the element. Now, something I almost forgot, by the way. The question in the empirical formulas and the molecular formulas. Now, do not rearrange what you have been given. Do not rearrange what you have been given. For example, the percentage composition by mass of an oxide of iron. So ya kwanza ni element number 1 is iron. Element number 2 is oxygen. Watu wana rearrange. I have a problem with students who rearrange the question. We find students starting with oxygen followed by iron. But the question normally guides you on which one comes first. So do not interchange. Do not change those things or those elements. By all means, change, especially when you'll be talking about now the organic ones. Organic chem where you have carbon, hydrogen, and oxygen. Fanya tu venye imeletwa carbon, hydrogen, and oxygen. If the question is starting with oxygen, hydrogen, and carbon, weka tu, which is not very possible. So first of all, you identify the percentage by mass. Of course, this one now was easy because you're given, you don't have to show you got the 30, 70, 30. And then you identify the relative atomic masses, 56, 16. Relative atomic. The reason why I'm repeating atomic is one atom. They have no relative molecular mass, which for the oxygen ingekuwa nini? 32. It is relative atomic mass. Number of moles, you say number of moles is actually the percentage composition over the mass, RAM. Well, you get 1.25, 1.875. Now, if you divide, you get 1 and you get 1.5. To make it a whole number ratio, when you have a decimal of 0.5, hapo ndo nilisema, you multiply by 2. You don't round off. I'll show you why it is multiplied. So the actual answer now, when you multiply by 2, is FE2 or 3. Now tell me where you messed up. Because I know you messed up. Now let me show you why we are multiplying by 2. Before you talk even, before you say what you have done. Because I mentioned it above that if it is, then if it is 1.5, if it is 2.5, if it is 3.5, you don't round off. You multiply. Now, this one is because of this. This one is 1. 1.5 is actually 3/2. So 3/2, I can say to make it all, I remove the 2. I multiply this one by 2 and I multiply here by 2. Anything that is 0.5 is actually and a half. So it is and a half. So you multiply by 2 to remove the half. So that is why this one and this one goes. And then you remain now with 2, 3. Tuko sawa sasa. Now it is good I let you do this one because it was I didn't even realize that it was going to bring a half, by the way. But it is good that imeleta. Muko sawa sasa because I got 2 answers. So I'm asking the people who sent the answers. What happened? But I explained during the first one.
Teacher,
Yes.
but you said as in from kuanzia 5 ndio tunafaa to round off. That's what I thought.
No, I said when it is half. You remember you heard when I said half, 0.5, 3.5, 2.5. Did I mention something like that first?
Yes.
Yes. I'm saying when it is half, it is easy to handle. That is why you multiply by 2 to make 0.5, 1.
Oh, so
When
assuming
it is, yes, first, go on first.
it was 1.6. Now we
Now you
just
round
round.
off.
Okay, now
Yes,
0.2.
but when it is half, it is because it is improper fraction in rahisi and in fact to make 1.5 all, you just multiply by 2 the 0.5 part. You take out the 0.5 part. When it is 0.5, when it is now something above 0.5, you round. We normally say we round up. I think it is rounding up. You're rounding it up to 2. If it was 1.4, 1.2, you round down to 1. And these questions have been tested. So anytime you have a decimal place, but the decimal is 0.5, you multiply by 2. I hope that one is okay. Let us do another example. We do other examples again. So it is very important for us to know. This one is good. I'm going to solve 1. I'm not going to solve question number 2. There is a reason. But this question number 2 is very easy. But it is confusing because they have given you CXHY. Yeah, it's normally interesting. That part is the interesting part of that question. So let us solve. Do I solve one? I think I can solve one. Yeah. Can you choose a question? I can go through the question first so that I can solve one.
Number 2. Mwalimu solve number 2.
I didn't want to solve number 2 because I wanted to give you that one. So that I can in a later confusion kabisa vizuri. Anyway, there is no problem. So first of all, I want you to be, before even I solve number 2, remember kitu nimesema, nitarudia tena. Please do not rearrange the question. I mean, do not rearrange the elements. Wacha venye elements inakuja. Let me show you what is happening here. So a compound weighing 42 grams, so you have 42 grams, of course you have been given a mass, was found to contain 12 grams magnesium. So ya kwanza ni nini? Element number 1 should be magnesium. Element number 2, carbon. Element number 3, oxygen. So that means it should be, this thing is actually magnesium carbonate. Yani from the arrangement. Imagine sasa, wewe uanze, umepewa hivyo, wewe uanze na carbon, oxygen, na magnesium. What is this? Do you know what this is? Have you ever seen this thing before? I don't think so, but you have ever seen this. So what I'm saying is, do not rearrange the elements. When you imeletwa on a question, just solve it. Now let me solve question number 2 and then you see what I'm talking about. I don't know if the space would be enough, but we will see. I don't want to use the whiteboard because I'm using the, if I had the other question, I'd have gone for the whiteboard. But let me see. Let me check if I have the question in the phone. But I have the notes in the phone so that I can use the whiteboard. Don't want to waelewe. So that one is better, eh?
Yes.
Yeah, let me check. If I have, I just need the question. So this one is KLB. Chem. So we need more. As we do that, I'm going to stop sharing so that I open the. Acha nipate hiyo swali. Haya, nimepata swali. So there's no problem. Yeah, I got the question. So I'm stopping to share first, and then now I open the whiteboard. New. Hopefully it goes well with me, eh? So I have to be checking the. If you have the question, also you can be checking. Let us check if it opens. everybody can see what I've opened, because I need to confirm that people can see. Can you see the whiteboard?
Yes, madam.
Yes, I need people to, now we change brings problems sometimes. Now, so this question is saying a sample of hydrocarbon of mass 51. So I'm going to write the masses, but we are going to solve it later on. So we have 51.2 grams. That is the total. That is the total mass. Was analyzed and found to contain 12.8. So we have 12. I'm writing this one, but I'll wrap them. 12.8 grams in hydrogen. So this one now is the whiteboard I'm using. Hydrogen. And then we have hydrogen. If the formula of the hydrocarbon is, so the hydrocarbon now is, its formula is CX. Is it CX? HY. You should not be worried about the handwriting or how it has been written, because I'm using the cursor. Find the values of X and Y. Find X and Y. So we are finding X and Y. X and Y, and then you're given C to be 12. So C is equal to 12, H is equal to 1. So they're saying this hydrocarbon, its mass is this one. Now, the mass of hydrogen is 12.8. So it becomes very easy. So what will be the mass of, they have given us that to be CHY. So we have H already, mass, its mass. So carbon inakuwa ngapi? What do you think could be the value for carbon? Before even I go to solving it. What do you think is the value of carbon? So you minus, it is 51.2 minus 12.2. I don't have a calculator now. You'll help me because I'm using my phone now to follow the question. So what is 51.2 minus 12.8?
Teacher, you said
Yes,
51.
51.2 minus
Mm.
12.8.
$38.4.
So the answer in this one is not very clear. So it's 38.2. I don't know if it is true. Is it 38.2 or 4?
38.4.
Oh, yes. So 38.4 grams. Now, ukishapata hiyo, you have everything to solve for X and Y. Now, so we go back to how we solve the empirical formula. We go back to how we solve for that empirical formula. So number one, we said we start with the elements. Now, the element in this case, in our case, is it has tumesaidiwa. Now, we have been guided by the carbon X and Y. So number one is carbon, and then number two is X. Now, you can do a line. You can do a line for the sake of, but most of the time, that means if you don't have your book, so you can do a line. For mine, I'll do a line. I do this. Now, I normally do this so that it becomes easier. Inakuwa rahisi. So I have to move the board down kidogo. Yes, so that it becomes enough. Now, ukishaandika elements, you have known the elements. What was the next thing? It is their mass. So we have the mass. So we have the mass of hydrogen. What were we given? I think we were given for hydrogen, isn't it? So we are given for hydrogen to be 12.8. 12.8. And then, so yeah, carbon hatukuwa nayo, but we can get it from 51. It got 51 point, I think it is 51.2. It's 51.2, yeah? Yeah, so it is, this one is 51, so that I don't confuse people. 51.2 minus 12.8. 51.2 minus 12.8. So what do you get? It will be 38 point. And make sure that we are correct, because I don't have a calculator. 38 point. I don't know if that is visible. 38.4. Now, after we are done with that one, you get the RAMs. So I'm going to write in RAM. Wacha niandike tu in short because of time and space, and we want to move. Now we have the RAM. So we have your carbon to be 12. So nilisema most of the time I use carbon 12. Na hydrogen inakuwa nini? 1. Tuko sawa mpaka hapo. Now number of moles is equal to I don't know if I have to write everything. So let me just erase this part. Number of moles. Let me just write, because M could mean something else. Is equal to mass. So I'm writing on this side so that nikiwa ndani ya the carbon part I'm solving it. Mass over RAM. RAM. Now, so this one becomes, what is the mass? 38.4. I hope you're still following. Over 12. And then this one now is 12.8 over 1. So I hope you can still see that one. So that I continue with the main drawing. Sorry. Let me check something. Somebody has texted me, okay. It is something else. Let me check. I'm checking something, I thought, okay, no problem. Let me just go back to my problem. I hope it comes back. Existing one. I'm sorry. Yeah, so we are okay. So we have that one now. So we have so what is 38.4 divided by is it 12?
Yes,
So
it is
ile ingine there is no problem. Ile ngapi?
3.2.
3.2. Na hii ni 12.8. Na ukifika hapo, so let me put the decimal ikuwe kubwa kidogo na hii pia ikuwe kubwa kidogo, ndo watu waelewe, yeah? This one is the decimal. I want people to, ndo nisichanganye watu. Even this one kuwe na decimal kubwa. Yes. So ukishapata hiyo sasa, this one is the number of moles, but actually this one is very big number of moles. This one is 3.2, this one is 12. That is a lot. We don't know, that is a very high concentration. We don't need that. So what we do is we divide now by the smallest value. So the next thing hapa, you can write, you might unaweza andika ama unaweza wacha. So what you do is you divide by the smallest value. So we divide by 3.2. Haya, wacha niweke decimal kubwa over also 3.2. So this one is easy. This one is 1. Now, what is the value of the other one? Right? I don't know. I can do this again.
It is 4.
4. So this one is easier. This one actually is very easy. So if it is number of moles now, so the number of moles, nani alikuwa anasema hii kitu ni ngumu sasa? I want that person now to say something. Number of moles of carbon is 1, and for hydrogen is 4. So I don't want to go down because nataka kwenda hii side. So I want to do this. I want to do this and this, so that it can divide this side from the other side. So you'll find now the number of moles carbon is 1, hydrogen is 4. Remember, but hii sasa venye tulikuwa tumepewa kwa swali ni CX and H. Sorry, now this one nimefika mwisho fika mwisho ya ubao bana. So let me wrap this one and then I write it somewhere else. Let me wrap this one and then we write it because I want people to understand this one. So we'll have C, we have C1, H4. Na ukumbuke tulikuwa tumeambiwa ni CF. This one is not actually what we are looking for. We are not looking for 1 to 4. We are looking for something different in this case. C and then HY. So C and C, we are not even interested in this one. So where there is C, we have, so X in this case is equal to 1. Y is equivalent to 4. Now, nataka muniambie kama imeeleweka ama nirudishe tufuate polepole. I'm going to, I had zoomed, so let me try to zoom out so that we can see. Is this still visible enough?
Yes, it is.
So can I zoom out one last time so that people can see? So that we check if it is working. Yes, let us check if it is. Ama itakuwa ndogo, but it's still visible. I think it is still visible. Yeah. I just wanted people to, have you understood how this one is done? So when they tell you to look for those values hapo chini, there's no problem. You can get the values. Now, this one is like now. So we have C1. So in C1, I wanted us to follow, and then we have H4. So this one is the empirical formula. Actually, what have happened here is they have only said, instead of telling us the number of carbons that are reacting, we are saying now we call that number of carbons X, and then we call the number of hydrogens Y. I don't know if I have another question that looks like that. I will look for another one. Let me check so that we tuone kama tunaweza pata
Teacher,
as you go. Yes, please.
yeah, my problem was finding the mass of carbon, but ushatuonyesha hapo. That's why nilikuwa naiona sama ngumu.
Oh, then that one is very easy. So when you are given a total mass of the hydrocarbon, that is, it is the mass of both of them. So ndo upate hiyo ingine, you must minus the other one. I'm looking for another question that looks like that. If I get, I'll be very happy. Of course, you can also check for me in the made familiar. Go to the malls. Oh, Monica, you have the made familiar around you now. Do you?
Yes, yes, yes.
Yeah. Please go to the malls. Topical questions. I want a question that is similar to this one.
Okay.
Yes. I'm also checking in the other ones, but I hope you have understood what we are talking about there, because it will be really sad if we have not. And these are the kinds of questions that normally comes mara mingi. So I'm checking in the what do you call med family. You check in the med family. Let me check in the long one. Mhm. Okay. Let me check. I hope we do get one, so that we can solve the same way, so that people can understand. Now, if you have understood how to solve this one, it becomes even better. Let me check. When a sample of hydrocarbon is analyzed, this one work out. 25. No, we'll do another one that has a longer, that has more. Yeah, I have one that is very good here, but it is not the same. But I think we will do that one also. So is it okay? Can I go back to do we go back to the notes first, so that as we look for another example? Because now I need people to see. Did I send the long one? I don't know if I did. Have you gotten something? But I wanted people to understand this one. We can still do another one. If you have the question and you can post it, I think we don't really have to write the question, but we can, I'll just do the way we have done, because everybody had that question before. I have another one that is very interesting, actually, which I think we must do. Did you get anything, Monica?
Teacher, I'm still checking. Let me just a minute. I've been winding up.
Okay. No problem. But you have understood this one, so that I can stop sharing this one in the meantime. We go back to one note, our normal note. I want to go to long one to share something on long one. Yes. If you can't see the screen very well, you can zoom in. So you can zoom in that way. I was zooming out so that we can see everything. So you can zoom in. So the handwriting not really okay, but that's done done the service. I wanted to show you. So instead, if you don't like leaving yours open, you can do what I've done. You just do the line. So even the one line can be here. You have the math so that you don't get confused. You have the RAMs. You do a line. But now the good thing is your book normally has those lines. Mine do not have. So you have the number of moles, you do again a line, and then so it becomes easy when you are, but your book has the lines. Now, my board do not have. Yeah? So that is why I had to. But this one is one of the simplest questions you can do. Now I'm going to go back to our original. If everybody is okay, we do another example, and then you do one for me. Yes, please. I don't know. Is that okay?
Yes, sir.
Yes, let us go now to another example. I don't know, we can do it. Is indicana, we come back to the whiteboard. There's no problem. We just use the same whiteboard. We are not going to, so we close the whiteboard and then we go back. I saw something in the long one. That is very interesting. I saw a very interesting question in long one. So I'm trying to. I'm trying to check if we can see the same. I'm changing the book. We are no longer using the KLB. I was going to the long one. There's a. I don't know if you can see. Can you see the screen very well? There is a question I'm interested in. So actually what we are doing is this one. It is the same with this one. Example number 2. Do you come out on Isaona or it is not yet open?
Yes, inaonekana mwalimu.
You are saying when another compound containing carbon and hydrogen was analyzed. Are you seeing a question like that? It was found to contain 75% of carbon and 25% hydrogen. Find its simplest formula. Kama mnaona what I am saying? This one is the same thing that we are solving, only different way. This is a different method of doing that, but I'm not interested in that one. I want us to do example number copper, carbon, and oxygen. We can do this one. Let us do this one. I want you to try doing this one before I do another one. There's another one, tougher one, a little bit, but you can try this one. Let me just give you, because of time. Or I solve this one, and I solve another, and I give you an assignment.
Yes, sir.
But you can see this one. An example, a compound was found to contain 3.2 grams of copper, 0.6 grams of carbon, and 2.4 grams of oxygen. Find this empirical formula. They have given you Cu to be 64, carbon to be 12, oxygen. I don't know if we are going to use the other one, but let us just see this one because I'm interested. There's a question I want us to do. So you have the mass of copper to be 3.2. Nilisema, let me repeat it this way. Nilisema, venye swali imeundwa, or the way the question has been set, do not compromise with that question by interchanging the element that comes first. Wachana na elements zipangwe venye zimepangwa kwa swali. And arrange the elements the same way it has been arranged. I mean, that is, it contains 3.2 of copper. So element number 1 is copper. 0.6 grams of carbon. Element number 1 is, element number 2 is carbon. And 2.4 grams of oxygen. So element, the last element, which is number 3, is oxygen. So we andika tu venye imeandikwa. Now, composition by mass. Now, this one is composition by mass. Besides, we have composition by mass and composition by percentage. So we have mass, so you write the mass. So this one is very clean. And then you have getting the moles, you divide mass by RAM. Yeah, so it is mass over the RAM. So you get 0.05 carbon, you do the same. And then now you divide by the smallest to get the whole numbers. Nilisema, let me just repeat this one. You divide by the smallest. You don't. Now let me talk about this place before even I do my example. We are going to do the using the whiteboard. Hopefully, you don't divide from this place. Let me just unaona hapa. I know there is a problem that will come in now, and let me just do it before somebody asks. This one unaweza pata 0.5 na hapa upate 0.25. Now I want to say this one before we go down there. Ukipata hivi, the rule that I mentioned previously, that I said when it is 0.5, you multiply by 2, does not affect it before you divide by the smallest value. Wacha nirudie tena. hapa juu, you see this place, ukipata 0.5, this one, for example 0.5 and 0.25, there is a rule that I mentioned that ukipata hapa 0.5, you multiply by 2 all sides, that is from oxygen, carbon and copper. That rule does not affect before you do the division, ina affect kutoka hapa sasa. For example, ukipata 0.5 hapa na upate 1 hapa na upate 2 hapa, it affects now after you get the mole ratio, this one. So ukishapata the mole ratio, it is now effective. You can do the multiplication by 2 when you have a decimal place. Sijui kama tuko sawa hapo, because I thought I wanted to mention that. Now, so let me wrap mine. I was just explaining. So after you have done that, now it becomes, so the empirical formula you have Cu. So what we were doing ourselves the other time is we were saying, so it is Cu1 carbonate, carbon 1, and then you have oxygen to be 3. And then you remove those ones that can be removed, especially the 1s and 1. You don't have to write. But if you write in the empirical formula, there is no problem. Ukiandika hivi, ndizo hata huyu ako correct na huyu ako correct. But when you are writing all the chemical formulas of compounds, we don't show these. Huh? We don't show the 1, we don't show the carbon 1, because now we are talking this one as 1, which is a radical. Unless there's a query, there's a question I'm interested in. Before I want us to do that, we must do that question by all means. So we go, so I wanted, so it's 14 content, find the estimates, 14.82 grams of an hydrocarbon content. Find the simplest formula of this hydrocarbon. Can you try this one? I think you can try this one. Find the simplest. Now, nilisema, sometimes the question might not ask you to find the empirical formula. But remember, the simplest all number ratio. So the simplest formula that we have in chem so far is empirical formula. So anytime they ask you the simplest, you can get that one. Do you think you can try this one? You can try that one, and then I solve another one. I will use the whiteboard, so I'll have to go back to the whiteboard as you solve that one. Let me try and copy that question. So you are solving this one. You can try this. Let me highlight. I want you to try. This one is the same question kama ile yenye tulifanya. But now in the other place, I want to try and copy paste the question so that we use it in the whiteboard, so that you see how that question is solved. Because sometimes inakujanga hiyo. And then I'll give you, this one has very good questions. We'll use the long one today for the assignment. I think you use the long one, and I will advise you to do the assignment so that when we meet, or when the next teacher comes in the next subtopic, which is molecular formula, we'll be using the same thing. In fact, I will do one example and then we just use it in the other one, in the molecular formula for that case. Are you done with this question? Because I want to copy something else.
Yes.
Yes, so you do that one. I'm not doing that one. I'm leaving that one for you. But I want the answer. And I'm not that one. There's something else. I wanted you to copy that question. I think it is this one. Yeah, it is this one. Let me try copy, and then you wrote down the question that I gave you, huh? Because I want
Yes,
to go back. Yes, so okay. Let me just, I want to stop sharing and then I go to something else. And then existing. check if we have so finish that one and then I'll show you I'll share the other one.
Teacher,
Yes, yes.
I think I did not finish copying the question. Are we given the relative atomic mass?
Let me
The
check. RMs. What are we looking for? Can get the people know that one. It was which question? Carbon is 12,
Okay.
and then hydrogen is 1. So hydrocarbon.
Yes,
Yes,
yes.
yes. So that one, yeah. It is okay. Sorry about that. Yes, I'm interested in that question because of the rule that we mentioned. Do you remember the rule that we mentioned? There's a rule that we mentioned. So I want to see that how if people can apply that rule in that case. It will be nice. It will be nice if people could. But I'm going to solve that question for you if there's a problem. So tumalize kwanza, and then I can. Before when we do mine, I can do that one first. So please let's hurry kidogo because of time. But let's still solve that question. If there's a problem, I think I'll still solve the question. Both was still there. Okay. So let me do the question as we continue. So I think we got ourselves one of the answers. CH3 from what? Is it CH3? I think I saw somebody else giving us something else. Let me just see. Monica Daniel, you're saying H5C? I'm solving that question actually. Let us see if we are okay. So let us solve that question first. Other before now I solved mine. I wanted to see so I don't know the question. Everybody has the question actually. So it is 14 points. Is it 14.82? So let me do this one. 14. Let me do this one. 14.82 grams. Wacha niweke vizuri. 14.82 grams of hydrocarbon contains hydrocarbon. Let me just write. I think this one is not as easy as hydrocarbon contains hydrogen. Let me write now. Hydrogen is equal to, is it hydrogen or carbon? Let me confirm. Okay, carbon. So it is carbon. Sorry. So carbon, wanasema carbon ni
12.26.
12.26 grams. Alafu hydrogen, when you talk about hydrocarbon, actually it is the name, the suggestion of the name, and actually what is written is different. Now let us continue. So in hydrogen will be 14.82. This one is 8, so that people cannot get confused. 0.82, I can do the decimal. Minus 12.26. So hii inakuwa ngapi?
2.56.
2.56. 2.56 grams. So actually this one, so 2.56 grams. Iko sawa. Ukishafanya hivyo sasa, it becomes easy. So kama kawaida, the first thing, element. Na nimesema unaanzia element yenye umepewa. Yenye tumepewa, so it is carbon, alafu hydrogen. Actually, we don't have, it is only, that is why I'm saying the name is bringing confusion. Jina inaleta confusion how it is formed. That is number one. You do the element. Now, the other thing is mass. That follows. So let me just solve it here. So we have the mass. So let me underline that one. Then I underline another one for RM. So mass. So tumepata mass ya carbon ni 12 point. Is it 26? Yeah. Alafu hii ni 2.56. I want you to see how it is solved, so that in case of anything, I have sent the books so that I don't forget. I have a lot of things. I do a lot of things, so sometimes I forget to send. Alafu tuko sasa, yenye inafuata ni RM. RM, let me just, so RM ya hii ni 12 na hii ni 1. Iko sawa mpaka hapo. Now remember number of moles. So let me teremka kidogo. And then I do my line again. So remember number of moles. You watch it to nifanye. And I'm saying the reason why I want us to understand this one is because yenye inakuja, that is the molecular formula, inategemea hii. Like you cannot get the molecular formula without doing the empirical, without calculating the simplest one. First, you do the simplest, and then now you get the molecular formula, which most of the writings that we use in the theory, in the practicals, all of them are the molecular formulas, not the empirical formulas. So, but you cannot get the molecular formulas without getting the empirical formula. So moles tunasema ni mass over, we said this, mass over RM. I think I should improve my I should buy another one now. This one is old. It was touched previously, but it died. So now mass of, so you now do this 12.2. Let me just write it mingi. 26 over 12. And then you have 2.56 0.56 grams over 1. That is the number of moles. So let me just do another one. Let me just do another line. So tuko sawa mpaka hapo. So what is 12.26 over divided by 12? Of course, this one is very easy. It is 2.56. Rahisi ni 2.56. So hii ya kwanza ni
1.022.
1.022. 25. 22. So I can put 22. Yeah. So ukishafika hapo, the rule continues now. We have that rule that was saying you divide by the smallest. So dividing by this, yes, in 1.022 alafu hii ni 1.022. No, I'm doing this one, although I wanted to do something else, there's no problem. Lazima kwanza watu washike hii. Now the first one is easy. So hii ni 1, hii sijui ni ngapi. Let me just do another line. Yes?
The other one is 3.
3. I don't know which is
2.50.
no 3.
You round off.
No, you are still forgetting. There is something I said. That is why I gave you that question. So the 2.5. 2.50.
Yes.
Yes, I want us to go back to what I talked about. There is something I mentioned, and I'm seeing people have forgotten. When it is 0.5, you don't round off. Or you don't round up or you round down. You don't. Yes? I think, Maura, you should mute yourself first. And then, there's some interference. Yes, thank you. Now, I'm saying, when you have that one with a decimal of 0.5, you don't. It is like saying we have 2.5. Here, this one actually, let me just repeat that one. 2, I like this question because now it has brought out an as 2.5. So this one is like 5/2. Yeah, I don't know, in proper fraction. So this one is equal to that one, which is equal to 5/2. I think it is that way. So when you have something that is 0.5, it is 0.5. It is 1.5. It is 2.5. 3.5. You don't round up or down. You multiply by 2 this side and also by 2 this side. So whatever you get now would be C2 H, is it H5? I don't know. You multiply by 2. You multiply by 2 when it is a decimal of 0.5. When it is 0.5, you multiply by 2. So the moles, this one is a continuation, number of moles. Sijui sasa kama Mwaura, I'm on you now. Because now I'm finding that people are forgetting. Monica, did you remember that rule?
Yes, teacher, but no, I was confused as then the question started by saying a hydrocarbon. So me,
Yes,
I started.
I know.
That's
Yeah.
where I missed.
So the name Actually, the name of a combination of carbon and hydrogen is not called carbon hydro. No, it is called hydrocarbon. That is why we have alkanes, which is an hydrocarbon, lakini C inakuja mbele. Mwaura na ammonia. I'm going to zoom out. Is this zooming out? Yeah, I'm going to zoom out so that you can see the whole. So that we have the whole. No, that one is too far. That one is good. No, I zoom in one. If I zoom in one, it disappears now. I want everything to be in the page. I think that one is fair enough. Mwaura,
Yes.
I'm on you because of that 0.5. Wewe ndo ulicorrect ile time, lakini sasa ukakataa kutumia 0.5 ukasema una round. Is it rounding up? You round off, which is rounding up to 2.5 ndo equal 3. When it is a decimal of 0.5, you don't round up or down. You do the multiplication by 2 when it is 0.5. If it was now 0.6, 0.7, 0.8, 0.9, that is when you round off. When it is 0.4, 0.3, 0.2, 0.1, you round down to 2 or that particular whole value now. The reason for doing that is because of what? The law or the definition of the empirical formula is it is simple, all number. So we want something that is all number. I cannot write 2.5. So we are looking for a complete value. That is why inakuja hivyo. Imekuwa heri. Oh, let us do another question. This one. Can we do one? And then now I was supposed to do one, but that mine is very long. It is a very long one, and I am seeing time is not on our side, and I know you have another class later on. So let us just do one example for the road. Yeah.
Teacher,
Yes.
can I ask a question? Assuming tumekuwa na 2.3, tutachukua 2 tuta round
yes,
down.
we round down now to 2.
Okay.
Ukipata 2.7, 2.8, you round up.
Yeah.
Yeah, equals sasa, for example, if it was 2.7 equal 3. If you get 2.5, 2.5 is a special case. That is why I chose that question. Because nilikuwa najua pia italeta maneno. Okay, let me check one last thing. One for the road. Now I wanted to do this question, but we are not doing that question now. This question is long, but we will do it. Remind me, we'll do that one. Let us do this one. One last one. Yeah, I don't know. I think you can try this one. Let us try this one. Let us try this one. So you see that one. Ile yenye mko mnafanya hii. In case we multiply both sides by 2, we do not round off 2.5 to 3. We do not round off a value that has 0.5. 1.5 I took round off to multiply by 2. To get a whole number, multiply both ratios by a certain factor to get whole numbers, which is normally 2 most of the times. Yes. Let us do this one and then we call it a day because of the one I wanted to do. No, it is very long. We need some time. I think we can do it another time. Is that a problem? So let us solve this one.
Example 5.
Yeah, example number 5. Calculate the empirical formula of a compound containing 43.4% sodium, 11.3% carbon, and the rest is oxygen. We solved that one. I think that one can be the last one for today. And then we meet the So I was just doing that one. Let me just confirm something. The assignment that we're going to do, because I've sent the long one, you can download. I've sent also the KLB. My KLB is a combination of, you can go and cut, because I sent using the phone. So it is a complete combination of all KLBs. So in page, what is it? Page 79. I think it is page 79 of the long one. I think I'll do page 79 of the long one. There's some exercise 2.1. So page 70, is it page 72 or 79? Yeah, page 72, page 79 in the phone, but it's actually page 72 in the book. But I think I can still do the screenshotting. Let me just check. So continue solving that one. It is page 72. I don't know. Let me do this. Let me just share that one this way. So that we can do more. Calculate the empirical formula. I don't know. Yeah, here, let me just give you. You can look for carbon, hydrogen, and oxygen. Those things are very simple. Let us do even question one alone. I don't know what we've gotten because of time. So calculate the empirical formula of container, sodium, carbon, and the rest is oxygen. We have sodium, they've given you 23. Carbon is actually a very easy one. If you know how to write sodium carbonate formula, this one is, you'll get that one correct. So I think I can get feedback. I'm not even going to handle this one today. I just need the feedback, and then we end it there for today. It is okay. Time is very on our side, and I know you have another class. I don't know if somebody has sent something. I don't think this one is us. Okay, no, that one was that. I'll go through. There's no problem. So you can try this one. Because of time, I think I can allow you to send me this one. That is okay. For the others that I've shared, there's one I've shared. If you can't get the RMs, I can give you the RMs. So if ukishindwa kupata RMs, you can just, but I think you can get the RMs everywhere. For the carbon is 12, hydrogen 1, oxygen 1, oxygen 16, calcium 40, carbon 12, oxygen is 16, aluminum is 27, 27, yeah, sulfur, I think sulfur is 32, lead is 207, oxygen again 16, carbon, hydrogen, iron is 56. Yeah. So those ones. For now, so sodium Na2, I'll just brush through because you already have one answer from you. So we have to. So Maura, at least now we are on the same page this time around. Yes. It is very important. So I'm saying kama unajua kuandika the formula, you can even mark for yourself before you do the question. So unaweza pata ulikuwa unajua kuandika formula, lakini question umepata answer umepata ni wrong, so you can try, and then you see. Now I want to leave you with one question. This one, example number 6, was the one that I was supposed to do. So when let me just post that one again. You can try. This one will be the first question we will solve when we meet. But I would advise you to please try, and then when we meet, we can. So I shared that question. So unless there's a query, please try that. This one was the question I was supposed to do, actually. But because of time, we're already 10 minutes into the time, but we started again 10 or 12 minutes late. So I think we are on the right track. So we just replaced our minute. So unless there's a query, unless there's a query for this lesson, I want to wish you a very beautiful weekend. Unless there's a burning question. If there's none, let us end it there for today. Try that question number 6, example number 6. I've shared it as a photograph on the wall, so you can try it. You can try it there. Unless there's a question, have a very nice day. We can leave this class to your own pleasures.
Good day to teacher.
Yes, good day.